Good Thursday morning or afternoon, grade 8 students. I wanted to make a video here with the corrections for the homework from Wednesday, which was 7, 8, 9, and 10 from the practice section of our book, and then have a look as well at 14, 16, and 17 from the apply section. Those problems being assigned on Wednesday. So the practice side, they don't expect us to solve every one of these. They ask us specific questions in the first few. So number 7 says, what's the first operation you should perform to solve each equation? So we have our ax plus b equals c style, and we know that the first thing we have to do is remove or get rid of the constant that's on the same side of the equation as the variable. So that is what we're talking about when we say the letter B in the sequence ax plus b equals c. So this is the style problems we're looking at. We know that getting rid of that constant is job number 1. So what's the first operation we should do to solve these? Well, in A, we would want to add 2 to both sides. And of course, the notion of adding to both sides is to keep our equation balanced. In B, we would want to remove 3 or subtract 3 from both sides. In C, we would want to be adding 10 to both sides. And in D, we would want to be adding 1 to both sides. They'd ask us what the second operation would be in number 7. So after we undid the constants, now our job is to isolate the variable and get it by itself. We already know maybe what 4r equals and minus 3x, but we always want to know what one positive variable represents. So in A, our job will eventually be to divide both sides by 4. That would eliminate our 4r and get it down to 1r. In B, we would want to, again, same idea, divide by minus 3. In C, we will want to divide by 2. And in D, we'll want to divide by minus 9. Number 9 asks us to solve these equations and then check the answer. So I'll look at A and D and try those. Again, students are encouraged and expected to be checking the back of the book around page 507 to find the answers to these problems. And this video is to show the solutions, not so much just list off what the answers are, but just show and explain a little bit more of the process there. So let's look at A. So we have 6r plus 6 equaling 18. I'm going to show in red my first step, which is to undo that constant with a 0 pair. So 6 minus 6 is 0, and that's how I get my equation simplified down to 6r equaling 12. Step number 2, again, is to isolate the variable through opposite operations. The opposite of multiplying r by 6 is dividing by 6. If I'm going to divide the left by 6, I need to divide the right by 6. 6 divided by 6 is 1. 1r is what we're looking for. And 12 divided by 6 is 2. So now if I'm going to run my check, again, we do that through substitution. We go back to the original equation and ask yourself, by substituting r for what we feel it is, 2, see if we get a balance. So does 6 multiplied by 2, again, that's to represent 6r, 6 times 2, plus 6 equal 18? Well, 6 and 2 is 12. Does 12 and 6 equal 18? Yes, it does. 18 equals 18. We know for sure that r must equal 2, and that's the proper solution. Again, if we made a small error and by accident we thought the solution was r equals 3, we would have substituted into there. Instead of r, we would have used 3. Then we would have 18 plus 6, and we would have solved the left side to be 24, and recognized immediately that 24 does not equal 18, therefore we made an error somewhere. And we go back and try to find it. I'm going to erase this problem and put our solution and check in for letter D. So D looks a little different, but the style is the same. Minus 37 equals 8f minus 139. So whether it's ax plus b equals c, or c equals ax plus b like we see here, the steps are still the same. I'm going to undo my constant with a zero pair. So I'm going to add 139 to both sides. That'll force that cancellation, where 139 minus 139 is 0. I'll have 8f left over on the right-hand side. And when I combine a debt of $37 with cash of $103 or $139, I have $102 left over. So my next step is to isolate the variable by opposite operations. 8f divided by 8 will give me f on its own. So if I divide the left by 8, I'll divide the right by 8. And I'm going to get out my calculator just to double check. 102 divided by 8 is 12.75. So f will give me 12.75. So again, we're seeing some decimals here, but not fractions. And again, with using our calculations for these divisions, fairly basic divisions for sure. Let's move on to number 10 and see what we have here. Same, just more of the same. So this time, let's have a look at B and C. I'll erase the solution for 9D. And we'll do the same thing with the check. Verify your answer simply means check. So we'll do the check up here once we get a solution. So B has 29 equaling minus 14n plus 1. So again, the setup is a little different, but we do recognize, hopefully, that the constant on the same side of the variable is what has to be removed first. In other words, we're going to minus 1 off the left, off the right here, and 1 off the left. Now I know we started with ax plus b equals c, but the reason we try to get rid of that b first is so we can reduce this down to a one-step equation that we're used to, ax equals b. So 29 minus 1 is 28. Minus 14n remains, and 1 minus 1 is 0, so we have a cancellation there. So I'm going to divide both sides by the numeric coefficient, and I'm going to highlight again just so students are made clear. When I divide out the numeric coefficient out of both sides, I need to see the identical numeric coefficient in 3 places. Its original location beside the variable, underneath to show the division as a fraction, and on the left side as well. Minus 14 divided by minus 14 is 1, so now I have 1n, which is my goal. 28 divided by minus 14, positive divided by negative is a negative, so 28 divided by 14 is 2. So I'm getting the solution of minus 2 equaling n, or n equaling minus 2. And if I do the check, I'll see if 29 equals minus 14 times minus 2 plus 1. Does 29 equal positive 28 plus 1? Yes, it does. 29 equaling 29 is our balance. Therefore, we know the correct solution is n equals minus 2. And if I'm erasing these problems and moving on to the next one too quickly, just simply pause, rewind a few seconds, and watch the end again, or any part of the problem. For 10C, we have 8x minus 7 equaling a minus 31. So I'm going to undo my constant, my b, by adding 7 to both sides. I get 8x equaling to, well, I have a negative for sure because of this concept is, as we described before, owing $31, but having $7 means I've reduced my debt down to 24, but I still owe. So we have 8x equaling minus 24. I'm going to divide out the numeric coefficient of both sides and simplify my problem to the solution of x equaling minus 3. The check is a substitution check, of course. Does 8 times minus 3 minus 7 equal minus 31? That's a question. We have to do the individual calculations. We can't just rush down to say minus 31 equals minus 31 because it's through this checking that we would find out if x equaling minus 3 was the incorrect answer. So 8 and minus 20 and minus 3 is minus 24. Minus 24 minus 7 does give me minus 31. And when I see that balance achieved, then I know my solution is correct. So looking at our first applied problem from yesterday's assignment, number 14 has us looking to write out our equation. They told us what to use for a variable. Uh, and then to solve using our opposite operations. So it says the percentage of elementary school students who choose hockey as their favorite physical activity is 14%. This percent of students, so of course we know that's going to be used later, this percent of students is 2% more than 4 times the percent who choose skiing. And the question is, find the percent of students who choose skiing as their preferred physical activity. Tells us to use S to represent the percent of students who choose skiing. So in essence, they've done step 1 for us. So we'll say let S equal the percent of students who prefer skiing. So now we go back to our problem and look for our clues, right? So some important words here is the fact that we know the percent that prefer hockey, and that's what we're working on. There's a relationship between hockey and skiing. So what we're working off is the 14% of the boys that prefer hockey as their favorite sport. So then we go back and look to figure out what else we have. Well, we have 2% left over to use and the 4 times. So in other words, if we were to quadruple the percentage of students who prefer skiing and add 2% to it, now we'll be at the number of people or boys that prefer, I guess it's students, pardon me, who prefer hockey. So that's what we'll do. We'll take 4 multiplied by the percentage of students who prefer skiing and add 2% to it. Now we'll make an equation. Now we're equal. So we'll undo this with a 0 pair by subtracting 2 off each side. Show our cancellation. Rewrite the remaining pieces. Combine the right side to be 12. Divide out both sides by 4 to isolate S on its own. And we get S equals 3. So I like to write a small statement to answer the actual question, which is what percent of students prefer skiing? 3% of students prefer skiing. So I know it's difficult sometimes to write the equations. The solving is usually quite a bit easier than the writing. We certainly have a lot more experience solving, just due to the nature of the practice and applied problems. So it's really a case of understanding what we're working on. We're working on equations in the form of ax plus b equals c. Looking for our fact, that's the equal side. Looking for clues like double, triple, half, those keywords that help us know if we're dividing or multiplying. And then looking for that constant amount, whether that be more or less, usually indicates whether it's a plus or minus. So hopefully that makes sense, and we'll move on to the next problem. A classroom's length is 3 meters less than 2 times its width. The classroom has a length of 9 meters. Write and solve an equation to determine the width. So let's let W equal the width of the class, because that's what we're looking to solve. I like to start with a sketch, and this is a rectangular classroom, and then put in the pieces that we know for sure and go from there. So again, a classroom's length is 3 meters less than 2 times the width. Well, the width is W. So 3 meters less than 2 times means it's not quite, it's less than double. So that's double, but it's 3 meters less than double. Right? So 3 meters less than 2 times, or double, its width. The fact that they've given us is that the classroom has a length of 9 meters. So we know that as well. And that will form the basis of our equation. So if we have 2w minus 3, and that equals or is the same as 9 meters, so algebraically our length is 2w minus 3, and in real numbers it's 9 meters, we'll be able to solve for w, and therefore we'll know the width. Again, we already know the length. What we're wondering is the width. So let's start by solving our equation by undoing this constant by adding 3 to both sides. We have a 0 pair, and we have 2w equaling 12. We'll divide both sides by 2 to isolate our variable, and we'll find out that the width, or w, is 6. So in a nice short answer here, we'd say the classroom is 6 meters wide. So I always like drawing a sketch for anything involving shapes, especially when we're dealing with area or perimeter. This one's a little bit different than those, but we'll see lots of those in the years to come. So hopefully this process here makes sense, how we set the algebraic length to the real length and then solve for W. Last problem is number 17. An eagle is hunting a bird in flight. The eagle begins its descent from a height of 74 meters. The eagle reaches its prey at a height of 3 meters. This situation can be modeled using the formula 74 equals 3 plus 6t, where t represents the time in seconds. A. What do you think the value of 6 represents in the equation? So we're looking at the numeric coefficient, that's what we call that. So our equation they've given is 74 equals 3 plus 6t. So they're wondering about what that is. Now we know already that t is representing the time in seconds. We know that the 3 is the meters above the ground that the eagle reaches its prey. And we know the 74 represents the height the eagle is at when it begins its descent. So what would the 6 be? Well, if we want to use equations for distance, time, and speed, we have these pieces here. So what the 6 must represent is the eagle's speed of flight. So it seems to be able to descend at a rate of 6 meters per second. So what do you think the value of 6 represents? Its speed in meters per second. So then B, they want us to solve this problem. After how many seconds does the eagle reach its prey? Give your answer to the nearest tenth of a second. So that tells us right now, this clue here, nearest tenth of a second, that we're not going to get an integer for this. We're going to get a decimal amount for this. And certainly we know we're going to get a positive decimal number because time is not going to be expressed as a negative. So they'd like us to solve this equation. So we know what to do here at this stage, hopefully. We're going to copy down our equation correctly. We are going to undo our constant with a 0 pair. What we do to the right, we do to the left. I'm going to cancel those out. I have 6t remaining. 74 minus 3 is 71. 60 is 71. So if we wanted to know what 6t was, we'd be finished. But we don't. We want to know what 1t is. In other words, the time itself in seconds. So I'll divide both sides by 6. 6 and 6 divided by 6 is 1. 1t is what we're after. And I'm going to turn on my calculator again because I know I'm getting a decimal amount. And I'm going to do 71 divided by 6. And I'm going to get 11.83 repeating. So a little bit more than 11 seconds, not quite 12 seconds. So I'm going to go quickly back to my answer and see what the parameters are again. It says give your answer to the nearest tenth of a second. So what that means is I look at my place number in the hundredth position or the second 2 decimal places and I ask myself, is that number greater than or equal to 5? In this case, the answer to that is no. So when that answer is a no, we are allowed to simply put 11.8 as our answer correctly rounded. Now, if that would have come out to 11.85 or 11.86, we would have then bumped that 11.8 up to an 11.9. So formula problems are often great problems. They sometimes look more difficult, but they do give us the equations to use, and our job is to do simplifications and substitutions. So hopefully that helps explain those problems for Wednesday's homework. Don't forget, our Google Meets will go along schedule with your regular schedule. So tomorrow being day 3, I will have opportunities to work and help students in the morning for Class 8E and after lunch for Class 8F. Also, don't forget to send me any emails or questions you may have through that forum as well, as I check those constantly. So thanks very much, best of luck, and talk tomorrow.